In this video, we are going to look at the question 5s for the June CSEC math exam for the years 2022 to 2019. So here we have our first question for June 2022, which is question 5 for June 2022. We have a school nurse records the height of each of the 150 students in class A who was vaccinated. The table below shows the information. So this here would be a class interval, 60 to 80, 80 to 100, 100 to 120. This here would be a frequency. So the class interval 60 to 80 would have 4 students. The class interval 80 to 100 would have 20 students, and so on. Now, part A of this question, we want to complete the table below and use the information to calculate an estimate of the mean height of the students, and we want to give the answer to 1 decimal place. So again, here we have the class intervals. Here we have the frequency, and they add on this midpoint column, and then it's this frequency times x. Now this is frequency times midpoint. So whenever you have class intervals, you'll find the midpoint, and that will be a x, and your fx column will be multiplying the midpoint by your frequency. So 4 times 70 would be the 280, 20 times 90 would be this 1,800, 35 times 110 would be this 3,850. So 67 times whatever this midpoint here is would give you what's missing here. And to get the midpoint, all you need to do is add up your lower class limit to your upper class limit and divide by 2. So if I were to add 60 plus 80 and divide it by 2, I would get 70. 80 plus 100, which is 180, divided by 2, you would get 90. Likewise, 100 plus 120 divided by 2 will give you 110. Therefore, to get what's missing here, you would add 120 to 140 and divide it by 2. So if I have 120 plus 140, press the equal sign, get 260, and then divide it by 2, I will get 130. So the midpoint for this class interval would be 130. And now if I multiply the 130 by the 67, that will be my f times x. So I'll be multiplying 130 times 67, and I'll get 8,710. So that's 8,710. Now in order to work out the mean for frequency data, so I'll have the mean is equal to, my formula is sigma xf divided by sigma f. Now this sigma symbol is the summation sign. It means to add. So sigma xf means add up everything in the fx column or xf column, because fx is the same as x times f. And sigma f would mean add up everything in the frequency column. So I'm just going to put sigma f here. And we don't necessarily need to add this part up because they already give us that information here. So when they say that there are 150 students in class A, it means your total frequency, if you add this frequency up, you'll get 150. So if you add 4 plus 20 plus 35 plus 67 plus 20 plus 4, you're supposed to get 150. So you don't necessarily have to add this up because sigma f is given 150. So I'll come here and put 150. Now for sigma xf, I'll have to add that up. So I'll have 280 plus 1,800 plus 3,850 plus 8,710 plus 3,000 plus 680. And I would get 18,320. So I'm writing here 18,320. So now to work out the mean, my sigma xf would be 18,320 divided by sigma f, which is 150. And now we are writing this answer to 1 decimal place. So I'm going to have 18,320 divided by 150. Let's change that to decimals. All right, so that's 122.13. So since we have a 3 here, this 1 will remain the same. So 122.1. So my mean will be 122.1. And of course, we're dealing with height, and the height is in centimeters. So my units would be centimeters. So the mean height would be 122.1 centimeters. All right, so moving on to part B, we have in class B. So what we worked out before was for class A. Now, this is for class B. We say that the mean height is 123.5 centimeters. So let's recall that for class A, this will be for A, the mean height was 122.1 centimeters. And we say that for class B, with this 123.5 centimeters as the mean, the standard deviation is 29.87. And for class A, the standard deviation is 21.38. Now, what they want us to do is, well, before I answer this part of the question, what do I mean by standard deviation? Well, this means how, if we go back to this table here, we see that we have heights ranging from 60 to 80. Well, of course, this will be from 59.5 to 80.5, right? The lower class boundary to the upper class boundary. So we have a spread of data here. We have 4 students within this range from 60 to 80. We have 20 students within this range from 80 to 100, and so on, 35 between 100 to 120. So this is how the information is spread. Now, what we're saying here is that the mean height is 122 for class A. All right, 122.1 for class A. So what the standard deviation is doing is giving us how close the spread of the data is to this mean height of 122.1. All right, so it could be how much before, because how much lower than 122.1 and how much higher than 122.1 the spread of the data is away from the mean. So we have a standard deviation for class A of 21.38. Let's just see what I'm talking about. So for class A, so here I have my mean for class A, which is 122.1. This will be the spread of the data. So we'll go 21, because this is the standard deviation for class A, right? 21.38. So 21.38 less and 21.38 more. All right, so this diagram that's giving us an idea of the spread of the information. So we have the mean here in the middle, and on the lower end, we'll have 21.38 less, and on the higher end, we'll have 21.38 more. All right, so that will be 100.72 on the lower end and 143.48 centimeters on the higher end. Now for class B, we have a mean of 123.5 centimeters. And the standard deviation is 29.87 on either side of the mean. So what does that mean? Well, if you subtract 29.87 from the mean, 23.5, you'll get 93.63. And if you add 29.87 to the mean, you'll get 153.37. So what you notice about the spread of the data for class A as opposed to class B is that the spread of the data away from the mean is a lot closer in class A as opposed to class B. And they say using the information provided and your response in A, right, comment on the distribution of the heights of the students in class A and class B. So the comment that I'll make is that the spread of the data in class A is a lot closer to the mean as opposed to class B. All right, so here I have it. The spread of the data is closer to the mean in class A than in class B. So that will be a comment on the distribution of the heights. Now moving on to part C1, we have to complete the cumulative frequency table below and use the information to construct a cumulative frequency curve on the grid provided. All right, so I'll have that grid on the next page. Okay, so what we have here is the frequency, and I have the cumulative frequency partially filled in. So what we know, we start with the first frequency, which is 4. So that's why we have 4 here, and then we say 4 plus 20. That's how we get 24. So 24 plus 35 will give us the one that's missing. And 24 plus 35 is 59. And likewise, 59 plus 67 will give us this 126. And now 126 plus 20 will give us 146. So that's why we have 146 here. And of course, 146 plus 4 will give you 150. So that's how you do the cumulative frequency. So here we have our grid paper with our cumulative frequency on the y-axis and height on the x-axis. And of course, we have some of the points already plotted for us. I brought over my table so I could see what to plot. We have group data for our height, and here we have the cumulative frequency. Now, anytime you have group data and you're plotting a cumulative frequency curve, you're going to use the upper class limit of your class intervals to plot with the cumulative frequency. So the upper class limits will go on the x-axis and the cumulative frequency going on the y-axis. So I'm just highlighting the upper class limits. So it'll be clear that these are the values that we are using to plot with the cumulative frequency. Now, if you look here, you see you're supposed to plot 80 on the x with 4 on the y. So let's come here, 80 on the x, and therefore this is supposed to be 4 on the y. So now let's see. Every 1 centimeter on the y-axis, we are going up by 10 units, which would mean if we divide our units, which is 10 units, by the number of blocks, which is 5 little blocks, 10 divided by 5 is 2, which would mean each little block would represent 2 units. So therefore, if we count from here, the first little block is 2, and the second little block is 4. So you're seeing that we plot 80 on the x with 4 on the y. Now, if you come here, we're plotting 100 with 24. So 100 on the x with 24 on the y. So this is your 100 on the x, and if you come up here, this is 20. So 22, 24. See, that's correct. Now, for this point that they give us here, this line up with 140 on the x. So you're seeing 140 on the x supposed to be plotted with 126 on the y. So let's see. This is 120, 122, 124, 126. So 126. So 140 on the x lines up with 126 on the y. And for this point, we have 180 on the x. So if you come across here, 180 on the x lines up with 150 on the y. So coming up here, and this is exactly 150 on the y. So you can see the points that they gave us are the values of the cumulative frequency that they gave us. So what we really had to plot is the 59, well, 120 on the x with 59 on the y, and the 160 on the x with 146 on the y. Now you're probably looking at this point here and asking where that come from. Now, in order to close off the cumulative frequency curve, you're seeing after 80 here, if you look here, 80, 100, 120. So basically, you're going up by 20 in terms of the upper class limits. Therefore, if you were to go to the upper class limit that came before this class interval here, that upper class limit will be 20 less than 80, which will be 60. And you'll set that to 0 to close off the cumulative frequency curve. That's why you have 60 on the x with 0 on the y. So now let's plot 120 on the x with 59 on the y. So you're going to come here at 120 on the x. I'm going to go all the way up to 50 here. And here is 60. So 59 is just going to be 1 less than 60. Now remember, each little block is 2 units. So if I come down here, this would be 58. Therefore, 59 will be in between 58 and 60, which will be in the middle of this little block here. So this would be 59. And now we have to plot 160 on the x with 146 on the y. So here we have 160 on the x. I'm going to go all the way up to 146. So we're going to stop at 140. And then remember, each little block is 2 units. So 42, 44, 46 right here. So now that we have all our points plotted, we're going to make a smooth curve connecting all these points. So this seems to be the best I could get it on the computer, drawing it freehand, of course. And this would be our cumulative frequency curve. So now moving on to part 2, we have use your cumulative frequency curve to find an estimate of the median height of the group of students. So now remember, the total number of students is 150. And we can see that here because the last value for the cumulative frequency is sigma f, which is the total number of students. Because if we were to put sigma f here and add up all the number of students, we would get 150. So the median is equal to half the nth term. And of course, this n will be sigma f, which will be the total number of students. So basically a half of 150. So that's a half of 150. And a half of 150 is 75. So the median will be the 75th term. Now the median is not 75. It's the 75th term. How are we going to find out what is the 75th term? Well, we're going to turn to our cumulative frequency. So we're going to find 75 on the y-axis. We're going to draw a horizontal line across to touch the graph. And where it touches the graph, we're going to bring it straight down and read off the value from the x-axis. So if here is 70, here is 72, 74, here is 76. So 75 is going to be in the middle of the block. We're going to bring this line straight across. And then you're going to bring it straight down. And now we need to read off what this value is. Now, if we look at our x-axis, we are going up every 2 centimeters by 20 because this is 60 and this is 80. The difference between 60 and 80 is 20. And this distance here is 2 centimeters. So the number of little blocks is 10 and the unit is 20. So if you divide the unit by the number of blocks, which is 20 divided by 10, you'll get 2. Therefore, each little block on the x-axis is going to represent 2. So here's 120, 122, 124, 126. So therefore, our median is 126 centimeters. And that will be a median height. So now here we have for part 2, part B. The probability that a student chosen at random would be taller than 130 centimeters. So taller than 130 centimeters. Now we know for probability, our denominator is going to be total possible outcomes. And we have 150 students. So our denominator is going to be 150. What we have to figure out is what's the numerator, which will be how many students are taller than 130 centimeters. So again, we're going to turn to the cumulative frequency curve to estimate that. So we're going to find 130 on the x-axis because here's the height in centimeters. So 130 will be right here in the middle of 120 and 140. We're going to draw a vertical line straight up to touch the curve. And where it touches the curve, we're going to bring it straight across. And read off this value here. Now remember, each little block is 2. So here's 80, here's 82, 84, 86. So here's 86. Now, taller than 130 centimeters means more than 130 centimeters. So if here is 130 centimeters, then more than that will be going this way. So the 86th student will be exactly 130 centimeters tall. Now remember, we want taller than 130 centimeters. Therefore, the 87th student would be taller than 130 centimeters. Now remember, you can't have a fraction of a student. So from 86, the next step above is 87. So now from the 87th student to the 150th student would be taller than 130 centimeters. So now the number of students taller than 130 centimeters will be equal to 150 take away 87. So 150 take away 87 is equal to 63. So we have 63 students here. So now the probability that the height would be greater than 130 centimeters will be equal to the numerator is 63 because that's the number of students who are taller than 130 centimeters. So 63, and our denominator will be total number of students, which is 150. So that will be equal to, so we have 63 divided by 150, and we get 0.42. So 0.42 would be the probability that a student chosen at random would be taller than 130 centimeters. And this will be the end of this question 5 for June 2022. So now let's move on to question 5 for June 2021. All right, so question 5 for June 2021, we have 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. The table below shows the results as well as the midpoint for each class interval. We want to use the table to determine the modal class for the amount of money spent. So the modal class will be the class interval that has the highest frequency. So we look at the column for the frequency, see which one is the highest. We have 31 is the highest. Therefore, this class interval, 70 to 80, would be the modal class. So my modal class would be 70 to 80. So now for part B, they want us to calculate an estimate of the mean amount of money spent, given your answer to 2 decimal places. Now this is frequency data. Of course, it's group frequency data, so we have to use our midpoint, which will be our X. And we need a XF column, which is multiplying the midpoints by the frequency. So I'll have to have a XF column here, XF. So I'll multiply 7 by 55, and I'll get 385. So I'll write 385 here. Then I'll multiply 11 by 65. So you multiply X by F, right? So 11 by 65 will give us 715. So I'm writing 715 here. Then I'm going to multiply 31 by 75. All right, so 31 by 75. That's 2,325. 2,325. Going to multiply 29 by 85. That's 2,465. And then 22 by 95. That's 2,090. So now we know we have to add up all the frequencies. So that will be sigma F. So I'll be adding up 7 plus 11 plus 31 plus 29 plus 22. And that will give 100. So we have 100 students in all. And up here they told us we have 100 students were surveyed. So you see that they give us the total frequency up here when they say 100 students were surveyed. So when you add up all this, we get 100. And now for your sigma XF, we'll have to add up all these numbers in the XF column. So I'm going to be adding 385 plus 715 plus 2,325 plus 2,465 plus 2,090. And that will give 7,980. So that's 7,980. So we know the mean for part B, the mean is equal to sigma XF over sigma F. And now we have sigma XF is 7,980 and sigma F is 100. All right, so dividing this by 100, we just move decimal point 2 places to the left. So we get 79.80. And they want us to write our answer to 2 decimal places. So we'll actually include the 0. All right, and this was in terms of money spent. So this will be in terms of dollars. So $79.80 will be the mean amount of money spent. Now for part 2 of this question, we have Damien reports that the median amount spent is $84. Briefly explain why Damien's report could be correct. Well, in order to know what the median is, well, we have 100 students and the median is halfway, which is 50. What we need is the cumulative frequency to determine the halfway point. So I'll write cumulative frequency here. And our first frequency is 7. So I'm going to put 7 here. Then I'm going to have this 7 plus 11, which will be 18. Then we're going to have 18 plus 31, and that will be 49. And then we have 49 plus 29, and that will be 78. And then we have 78 plus 22, and that will give you 100. All right, so this 7 means my first term to my 7th term would be this class interval 50 to 60. All right, so my first term to my 7th term lies within this class interval. Then after 7 is 8. So my 8th term to my 18th. All right, because here's 18, my 8th term to the 18th term lies within this class interval 6th to 7th. After 18 is 19, so my 19th term to my 49th term would lie within this class interval here, 7th to 8th. Now remember the median is halfway, right? So half of 100 is 50. So now my 50th term to my 78th term would be within this class interval 8th to 9th. Now I don't have to go any further because this will have everything I need. But I mean, if you want to go further, the 79th term to the 100th term, right? So that's where ending 100 would lie within this class interval 90 to 100. All right, so I'm going to say my median is equal to half. And so when we're on the commuted frequency curve, we just say a half of n. And here n is 100. But here when we're on the table, we'll say n plus 1. All right, so n plus 1, right, term. So that's going to be a half of 100 plus 1. So that'll be a half of 101, which is equal to 50.5. And now because we get a decimal here, 50.5, we'll be taking the 50th term plus the 51st term and dividing by 2. So my median would be my 50th term plus my 51st term divided by 2. And looking at the table here, my 50th term would lie within this class interval here, 80 to 90. And my 51st term would lie within the same class interval, 80 to 90. So to work out the median, I'll be using the midpoint for this class interval, 80 to 90. All right, and that will be 85. So I'll be putting 85 plus 85 divided by 2, which will just give you back 85. So $85 would be a median. So now Damien reports that the median amount spent is $84. Right, briefly explain why Damien's report could be correct. Well, we will call the median and the answer is 85. So obviously, yes, his report could be correct because the median is 85. Now remember, what we use is the midpoint, 85, which is an estimation of the data within this class interval here. Therefore, because the data is spread out within this class interval, it doesn't necessarily have to be 85. This is just like an estimation, and that's why the $84 could be correct. So I have that Damien could be correct because the median is in the class interval 80 to 90. So moving on to part B here now, we have the two-way / contingency table below gives information on the mode of transportation to school for the 100 students. So we have boy, girl here, total. This is the column that's giving us how many boys and how many girls walking, how many boys and girls cycling, likewise boys and girls driving, and this is the total, right? So this will be total amount of boys, this will be total amount of girls, and this 100 will be total amount of students. Now, likewise, this total down here, this will add up the total for the amount of boys and girls who walking. This here will be total for the amount of boys and girls who cycling. And this is the total amount of boys plus girls who are being driven. All right, so this 14 plus 26 will give you the 40. All right, so likewise, 15 plus something will give you 23. So we just have to take away 23 from 15 to fill out what's here, right? So as simple as 23 take away 15. And I believe that will give you 8. All right, so 15 plus 8 is 23. Now going all the way across, 15 plus something plus 14 is equal to 48. So let's add up was 15 and 14 and take it away from 48, and I'll fill out what's here. All right, so 48 take away 15 plus 14 is equal to 19. And now we have 19 plus 18 will give us what's missing here. All right, so 19 plus 18 is equal to, and that will be 37. And now we'll have this 8 plus 18 plus 26 will give us what's missing here. Well, this is your table completed. So now for part 2, we have a student is selected at random what is the probability that he/she was being driven to school on that day? So you look to see how much students was driven, and that's 40 students was driven out of 100 students. So for part 2, right, I'm going to put P for probability, and that's going to put driven in brackets. All right, is equal to 40 students out of 100 students. So here the zeros will cancel. All right, so that's going to break down to 4 over 10. And like I say, 2 into 4, 2, and 2 into 10, 5. So that's 2/5. So the probability of a student being driven that day is 2/5. So now for part 3, we have one of the girls is selected at random. What is the probability that she did not cycle to school? All right, so we have 18 girls that cycle to school, and the total amount of girls is 52. So the probability of a girl cycling to school is 18 out of 52. So first I'm going to do that. So probability that a girl cycle is equal to 18 out of 52 girls in all, which is equal to, I can say 2 into 18 is 9, and 2 into 52 is 26. So that'd be 9 over 26. All right, so now the probability that a girl did not cycle would be equal to 1 take away the probability that a girl cycle. So that'll be equal to 1 take away 9 over 26. And if we pull that up on our calculator, we have 1 take away, use the fraction button, 9 over 26. And we get 17 over 26. All right, so that's equal to 17 over 26. So moving on to question 5 for June 2019, we have the cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150 different vehicles is shown below. All right, so what we have here is volume, and what we have here is cumulative frequency. Now for part A, they want us for the class interval 21 to 30, determine the lower class boundary. So 21 is your lower class limit and 30 is your upper class limit. Now the lower class boundary is 0.5 less than the lower class limit. So that 0.5 less than 21 was 20.5. So the answer here will be 20.5. And that will be liters. Now the class width is your upper class boundary, take away your lower class boundary. So the upper class boundary is 0.5 more than the upper class limit. So the upper class boundary is going to be 30.5 and your lower class boundary is 20.5. So your class width is equal to 30.5 take away 20.5, and that'll be equal to 10. And that'll be 10 liters. Now for part B, when they ask how many vehicles were recorded in the class 31 to 40, we find that class interval 31 to 40. So that'll be here. And what we need to know is the frequency. Now here's the cumulative frequency, right? So this 101 is not the frequency for this class interval. So what I need is the frequency. And my first cumulative frequency would be my first frequency. So that first frequency will be 24. And now 59 take away 24 will give the frequency that's supposed to come here. All right, so 59 take away 24 is 35. So 101 take away 59 will give the frequency that's supposed to come here for the class interval 31 to 40. So 101 take away 59 is equal to 42. So there are 42 vehicles within this class interval 31 to 40. All right, so the answer here would be 42. Now let's put 101 take away 59, which is equal to 42. All right, so now for part C, we have a vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill the tank is more than 50.5 liters? All right, so first we're going to locate the class interval for 50.5. This will be from 40.5 to 50.5. So actually 50.5 will start from here So 50.5 to 60.5 will be this class interval. So we need the frequency for this class interval, which will be 150 take away 129. All right, so 150 take away 129 is 21. So that means you have 21 vehicles that take in between 50.5 to 60.5 liters to fill. So the probability that the volume of petrol needed to fill the tank is more than 50.5 will be 21 out of the total amount of vehicles, which is 150. So I just have here that the number of vehicles requiring more than 50.5 liters to fill will be equal to that 150. Take away the 129, because that'll be the frequency, which is equal to 21. So now my probability that the volume is greater than 50.5 liters will be equal to the 21 vehicles out of the total, which is 150. And now I could say 3 into 21 is 7, and 3 into 150 is 50. So my probability will be 7 over 50. Now for part D, we have that Byron estimates that the median amount of petrol to be 43.5 liters. Explain why Byron's estimate is incorrect. So what we want to do here is work out what's the median. All right, so we have the commutative frequency. We could say, okay, since the first frequency is 24, that means my first term, all right, to my 24th term would be within 11 to 20. Then after 24 will be 25, so my 25th term to my 59th term will be within this class interval 21 to 30. After 59 is 60, so my 60th term to my 101st term will be within this class interval 31 to 40. And my 102nd term to my 129th term will be within this class interval 41 to 50. And of course, my 130th term to my 150th term will be within this class interval 51 to 60. So now we know the median is equal to half the n plus 1 term. And my n will be my total frequency, which is 150. So your last frequency of a cumulative frequency is your total frequency. But they also give that here when they say 150 different vehicles shown below. So it means our total frequency is 150, or n is equal to 150. All right, so we have a half of 150 plus 1. All right, so that'll be a half of 151. And that'll be equal to 75.5. All right, so my median is going to be my 75th term plus the 76th term divided by 2. All right, and that's because we got this decimal here, 0.5. If when we find a half of the n plus 1 term, you get like 75, a whole number, well, then the median is just be, well, that term. All right, but once you get the 0.5, you have to take the 75 and the one after it, which is 76, and divide by 2. All right, so how do we get the 75th and the 76th term? We come here, see where's 75 and 76. It will fall within this 60th to 101st term. So it falls within this class interval here, 31 to 40, both the 75th and 76th term. So now in order to work out the median, we need the midpoint of this class interval. All right, so the midpoint of the class interval 31 to 40 is equal to 31 plus 40 divided by 2. So that'll be 35.5 is the midpoint. All right, 35.5 liters. So my 75th term and 76th term will be 35.5. So my median is equal to 35.5 plus 35.5 divided by 2. So that'll just give it back 35.5 liters. Now, obviously, this value that we got as 35.5 liters is way lower than 43.5 liters as to Byron's estimate. Now I can simply say that the median is 35.5, which is not what Byron estimated as 43.5. Or if you didn't want to work out the median and just stop up to here with the 75th plus the 76th term divided by 2, you could say, okay, well, the 75th plus the 76th term lies within this class interval here, 31 to 40, and Byron's estimate is 43.5, which falls outside of this class interval. So I have that the median lies in the class interval 31 to 40 liters, and Byron's estimate of 43.5 liters is outside the class interval 31 to 40 liters. Now for part E, we have on the partially labeled grid below, we want to construct a histogram to represent the distribution of the volume of petrol needed to fill the tanks of the 150 vehicles. Now here we have frequency. Now our table did not give us frequency, it gave us commutative frequency, which means we have to calculate the frequency. Also, we'll need the lower class and upper class boundaries to plot on the x-axis. All right, so here I have my table. What we'll need is the lower class and upper class boundaries. So let's put LCB, and all right, we'll have UCB for the upper class boundary, and we have frequency. So my lower class boundary here will be 0.5 less than 11, which is 10.5. And my upper class boundary will be 0.5 more than 20, which is 20.5. All right, same thing here. So here will be 20.5, and here will be 30.5. Then I'll have 30.5, and this will be 40.5. Here will be 40.5, and here will be 50.5. All right, so 0.5 less on the lower class limit and 0.5 more on the upper class limit. All right, so 0.5 less here is 50.5, and 0.5 more here is 60.5. So those are my boundaries. And now with frequency, we obtain that, well, the first frequency is 24. All right, and now we'll say what? 59 take away 24 to get the frequency for here, which is 35. Then we say 101 take away 59, which is 42. Then we say 129 take away 101, which is 28. And then we have 150 take away 129, which is 21. So in order to plot the histogram, I'll be using my lower class boundaries, upper class boundaries, and frequency. All right, so let's bring in that information right here so I can see what I'm doing on the graph. So on my x-axis, I'm going to have my volume in liters. And now based on the space I have here, knowing that I have to go from 10.5 all the way up to 60.5, I can count in tens, all right, every 2 blocks representing 10 units. All right, so 10, 20, 30, 40, 50, 60, and 70. All right, so obviously we had to figure out was 10.5, right? So what we have here is 10 units, and from 0 to 10, we have 10 little blocks. So each little block representing 1. So 0.5 will be half of 1 little block. Okay, so 10.5 will just be in the middle right here. Okay, so from 10.5 to 20.5, we're going up to 24. And same thing here, right? From 0 to 10 is 10 little blocks. So each little block representing 1 unit. So you're going to draw a line from 10.5 all the way up to 24. So that'll be 1 less than 25. All right, and the width of this bar is going to be straight across to 20.5. All right, so it's 20.5 here, going all the way up to 24. Let's draw a line, close it off here. All right, so this is my first bar from 10.5 to 20.5, going all the way up to 24. All right, then from 20.5 to 30.5, going up to 35. So this is the 20.5 line here already. So that's how to go on 30.5, which is here. And I'm going all the way up to 35, which is here. All right, so that's going to extend this line up like this. And close. All right, then we're going from 30.5 to 40.5, going up to 42. So we already have the 30.5 line here. And we are going up to 42. So what I can do is let's extend this line up to 42. All right, so this is 40 here, 41, 42. And going all the way across to 40.5. All the way up to 42. Right, let's close it off here. Then we're going from 40.5 to 50.5, and we're going up to 28. So this is the 40.5 line here, and we're stopping at 28. So 28 is about, here's 25, so 26, 27, 28, that's right here. And we are coming across to 50.5. And now the last one from 50.5 to 60.5, we're going up to 21. So this is my 50.5 line here. We're going up to 21. So 21 is just about here. And I'm going all the way across to 60.5. And that's it. This is your histogram. And that's it for this video.